Hello ma'am, my first question is to define what is the saturated water, wet steam, dry and saturated steam and superheated steam with the help of diagram. Second question is to find out the different formulas for the enthalpy, entropy as well as specific volume as per the condition of the steam. Third question is to identify the type of steam, or we can also say that the quality of steam as per the given condition. To understand the saturated water, wet steam, saturated steam and superheated steam, we have to first understand the phase change process of water. Water is considered as the pure substance because its chemical composition remains same for all its phases. Now we will consider the piston cylinder arrangement to understand the phase change process. Now initial condition for the water inside the cylinder is 1 kilogram of water at 1 atmospheric pressure and at a temperature of 10 degrees Celsius. Now this piston is adjusted for a pressure of 1 atmosphere. Now when the heat is added, then we have to plot the different processes or different phase change processes that is taking place inside the cylinder at constant pressure of 1 atmosphere. Now as the heat is added for a water at 10 degrees Celsius, then what will happen? Its temperature will increase. Now we will plot here on vertical line, that is temperature, and on horizontal line the heat added. So we have to add the heat constantly. So this 10 degrees Celsius temperature water will reach to the 100 degrees Celsius, and as the heat is added, then its temperature will also increase. So we will draw the process A to B, that is point A is at 10 degrees Celsius. So we will show this process by this line, and here at 10 degrees Celsius there is the point A, and here at this point B the temperature of water is 100 degrees Celsius. Now how we can define this process AB? So this process AB, temperature of water is getting increased and the heat added is known as the sensible heat. Now what is the condition of water at this point B? So this water is known as the saturated water. So at this point B we have to write here, that is the point B is for the saturated water point. Now why this point B is known as the saturated water? Because after point B, when we add the heat, then the phase change process is taking place. That means water is started to convert into steam. So here this point B is known as the saturation point, and here the phase of the fluid or whatever inside the cylinder, that is water. So this point is known as the saturated water. So when we add the extra heat, the water is started to convert into steam and the temperature remains constant. So for the next process BC, we have to show the temperature, that is the constant temperature, until all the water is getting converted into steam. So we will show this process B to C for the constant temperature. So here we will show point C. So this water is at saturation temperature for this point B, and then heat added is known as latent heat. Now why this heat is known as the latent heat? Because here the phase change process is taking place. So during this process B to C, or in between this B to C, there is the wet steam, because the steam is having some water vapors or moisture is there. So in between this B to C, steam is known as wet steam. Now what happens at this point C? So at this point C, all the water is getting converted into steam. So this point C is known as the dry and saturated steam. Dry and saturated steam. Now there is no any water particles at this point C. So again we continue to add the heat. Then this steam is temperature of the steam starts to increase, and we will again move for the next process, that is the process CD. So its temperature is getting increased and it is known as the superheated steam. So we will show this process CD, that is known as the superheated steam. So here, as we continue to add the heat, the temperature of steam is getting increased and this process is known as CD. So we have to write here the process CD is for superheated steam. Now this graph is for the constant pressure, that is 1 atmospheric pressure. Now if we adjust the piston to increase the pressure, or we can say the 10 times of atmospheric pressure, then what will happen? So this point B, which is the boiling point, will shift towards the right hand side. So this is the 1 atmospheric pressure. Suppose we increase the pressure 10 times, then this point B will shift towards the right hand side, and this point C will shift towards the left hand side. So I will join this point B and C at the increased pressure. Then suppose we increase the pressure for the 100 times of atmospheric pressure, then again this point B will shift towards the right hand side and this point C will shift towards the left hand side. So again we will join. So if we join all this point B as well as all this point C, then we will get the saturated liquid line as well as saturated vapor line. So we will join these points. So this line is known as the saturated liquid line. And if we join all these points, then this line is known as the saturated vapor line. Now this saturated liquid line and saturated vapor line meet at a single point, and this point is known as the critical point. Now we will understand the formulas for enthalpy, entropy as well as specific volume with the help of diagram. Now we will consider the point B. So at point B there is the saturated water, and water, that means the liquid phase. So we will use here the suffix F. So enthalpy at this point B is known as HF, entropy SF, and specific volume VF. Now we will move for the next process, that is process BC. So what is happening during process BC? So water is getting converted into steam or water vapor. So if we select any random point in between this B to C, then there is the water as well as water vapor mixture. So we will select any random point, that is the point P. So for this wet steam, we have to first decide at this point P what is the amount of the water as well as what is the amount of water vapor, or we can say steam, is there. So how to decide? So for that we have to calculate the dryness fraction X, and it is also known as the quality. So here dryness fraction X, it is having the formula. So it is the ratio of mass of the dry and saturated steam to the total mass of water as well as water vapor. So we can say the formula mg divided by mg plus mw. That is, mg is the mass of the dry and saturated steam divided by mass of the dry and saturated steam plus mass of the water. So suppose at point P there is the any mass, then out of that total mass we have to take the mass of dry and saturated steam and we have to divide that total mass. Then we will get this value of X, dryness fraction. Now at this point B there is no any dry and saturated vapor. So at this point B, this mg value will become 0. So we can say that 0 divided by anything, that is equal to 0. So at this point B, X is equal to 0. And at this point C, here no any water particles are there. That means this mw will become 0. So no any water traces are there. So mg divided by mg, that is equal to 1. So at this point C, X is equal to 1. And any point in between this B to C varies from 0 to 1. So dryness fraction at any point is always in between this 0 to 1. Now how we can define the enthalpy? So this enthalpy for the wet steam is known as, or any particular point, so we will say suppose the point P, how we can write the formula. So we will write the formula, that is equal to HF plus X into HFG. So here at this point B there is HF plus X. So X value is nothing but the dryness fraction at this point P multiplied by HFG. Now in the same way we have to define the entropy. So entropy is SF plus X into SFG. Now what is this HFG and SFG? These are the enthalpy and entropy for this mixture of the water and water vapor. So here the suffix F is for water and suffix G is for water vapor. Then specific volume. So for the specific volume, X into Vg plus 1 minus X into Vf. So this is the volume. Now if we observe this formula, then this 1 minus X into Vf. So here specific volume of at this point B. So this volume is so much small. So we will neglect this term. And we can use the only formula, that is XVG, for the specific volume of wet steam, that is equal to XVG. So we can use this formula for the calculation. Now we will move for the next point, that is the point C. So at point C there is the dry and saturated vapor, or we can say dry and saturated steam. So at this point what is the enthalpy? So enthalpy is known as the Hg, because vapor is there, so we will use the suffix G. Then entropy is known as Sg and specific volume is known as Vg. Now we will understand enthalpy, entropy and specific volume for the superheated steam, that is for the process CD. So how to define the enthalpy for the superheated steam? So it is known as H superheated, and it is the addition of HF plus HFG plus CPS, that is the specific heat of superheated steam multiplied by the temperature difference. So suppose we will consider any point, that is the point Q on the superheated steam, then the temperature of the superheated steam at this particular point minus temperature of the saturated steam. So we have to take the difference in between this superheated steam, that is known as T superheated, and temperature for the saturated steam, that is here at point C. Now this HF plus HFG is known as Hg. So we will also say the formula Hg plus CPS, that is the specific heat of superheated steam multiplied by temperature difference of T superheated minus T saturated. So if we have to define this temperature, that is T superheated, then here I will join this with the help of the dash line. So this is known as T superheated, and this temperature at point C is known as the T saturated. Now we will move for the specific volume. So for the specific volume we have to take the ratio for the specific volume of dry and saturated vapor and specific volume of the superheated vapor. So here Vg is the specific volume at this point C and V superheated is the specific volume at the selected point Q. So Vg by V superheated is equal to T saturated divided by T superheated. Now entropy. So entropy of superheated steam, that is S superheated, is equal to Sg plus Cps, that is the specific heat of the superheated steam, multiplied by Ln T superheated by T saturated. So here is T superheated and T saturated. So this Ln is available in the calculator and we can calculate this. There are different formulas for the wet steam, dry and saturated steam as well as superheated steam. So before solving the question, it is important to understand or to identify what is the type of steam or the condition of steam. So let us first solve the problem to identify the type of steam as per the given condition. So here are total 3 cases, and with the help of steam table and this diagram we will identify what is the condition of steam. So for the first case here, 2 kg of steam is given, pressure is 8 bar and enthalpy is given 5538 kilojoule and temperature is 170.4 degree Celsius. Now if we observe here, the enthalpy is given and mass is also given. So we will first find out what is the specific enthalpy. So specific enthalpy means what? Kilojoule per kilogram. So this enthalpy is given for 2 kilograms. So for 1 kilogram, H is equal to this total enthalpy divided by mass. So here 2769 kilojoule per kilogram. So this is the enthalpy is given. Now at the 8 bar pressure it is given, we will compare the enthalpy at the 8 bar pressure with this enthalpy. Now for that we have to refer here the pressure table and we will consider the 8 bar. So here saturated water and steam pressure table is there and we will take here the 8 bar pressure. So here at 8 bar pressure we will compare the enthalpy. So HF is 720.9, so it is less than this 2769. Then HFG is 2046. So this is also less than, and Hg. So this Hg is given 2767.4. So I will write here Hg is equal to 2767.4 kilojoule per kilogram. Now if we compare these two enthalpies, then these two enthalpies are nearly same. So we can say that the condition of steam is dry and saturated. So Hg means what? Hg, that means the enthalpy at point C. So condition of steam is dry and saturated. Now for this, suppose there is any given problem for the given conditions, then we have to apply the formula for the dry and saturated steam. Now we will move for the next case. So for this case here, 1 kilogram of steam is given. So for 1 kilogram of steam, pressure is 2550 kilopascal and specific volume. Now here 1 kilogram of steam is given. So for 1 kilogram of steam, volume is known as specific volume. So 0.2742 meter cube. Now this kilopascal pressure, but in pressure table pressure is given in bar. So we have to convert this into bar. So pressure is 25.50 bar. So we have to take here the 2 digits here. We have to shift the point. The P is equal to 25.50 bar. So again we have to refer here the pressure table, that is at 25.50 bar. Now if we observe at this pressure, from this pressure table we have to find out the value of T, that is the temperature, saturation temperature. It is 225. Now here 25 and 26 pressure is given, and in between them the pressure is not given, but the middle value is 25.50. So So again we have to take the average for these two temperatures, that is 223.9 plus 226 divided by 2. So here 223.9, so approximately 224 plus 226 divided by 2, that is 225. So temperature is 225. And again the specific volume for the dry and saturated steam, again we will take the same average, then we will get here the 0.07835. So here this value of Vg that we have to take. Now if we observe here this at the pressure, given pressure 25.50 bar, this temperature is known as the saturation temperature, and this volume, that is the specific volume, is for dry and saturated vapor. Now if we observe here, that is the given volume, so we have to compare the volume. So at this pressure this is the Vg and this is the temperature, but given volume is 0.2742. So if we compare these two volumes, then this volume is much larger. So Vg, that means here is the value of Vg. Now this value is 0.07835 for this pressure, but this volume is much larger, so we can say that the steam may be superheated. So now we will calculate what is the temperature of superheated steam. So how to calculate? Now we have the saturated temperature, then volume of specific volume of dry and saturated steam, and this is the volume of superheated steam. So when we compare this Vg and V, then only we know that this is the superheated steam, because the volume is much larger. So I will say that this is the specific volume of superheated steam. So we have formula, that is Vg by V superheated is equal to T saturated by T superheated. So now we will put the value. So remember, temperature we have to take in Kelvin. So we will take here Vg, that is 0.07835, V superheated 0.2742, T saturated. So we have to take this Kelvin to 25 plus 273 by T superheated. So T superheated will also get in Kelvin, that is 1742 Kelvin, and which is equal to 1469 degrees Celsius. So this is the superheated temperature. And we can say that the condition of steam is nothing but this is superheated steam. So how to compare? Because we have to compare the specific volume. So this is the specific volume for dry and saturated vapor, and this volume is much larger. So volume is getting increased as we add the heat. Now we will move for the third case. So in this case, 1 kilogram of steam is given 60 bar pressure and enthalpy 2470.7 kilojoule per kilogram. So for 1 kilogram of mass, this enthalpy is known as the specific enthalpy. Now at 60 bar pressure, we will compare the enthalpy. So enthalpy at point B, enthalpy at point C, we will compare this given enthalpy. So for that we have to refer the pressure table. So in the first column there is the 60 bar pressure is given. Now if we compare HF, I will write the value. HF is 1213.7. So at this point B, HF is equal to 1213.7 kilojoule per kilogram. And Hg is equal to 2785. So at this point C, Hg is equal to 2785 kilojoule per kilogram. Now if we compare HF, that is the enthalpy of the saturated water, Hg, enthalpy of the saturated steam, saturated and dry steam. So if we compare this enthalpy 2470, so it is in between this. So we can say that the given location of point is in between this B and C. So we know that any point in between this B and C is known as the wet steam. So what is the condition of steam? So we can say that this is the wet steam. Now we will also find out the dryness fraction by applying the formula for the wet steam. So we know that what is the formula for wet steam, that is H is equal to HF plus X HFG. So this HFG value is also mentioned here for the 60 bar 1571.3. So we have to write all these values. So if we write all these values, X is unknown, that is H is equal to this 2470, HF we have to put this value, X that is unknown, and HFG 1571. So when we calculate X is equal to 0.8. So we know that for this given condition, that is the wet steam is there and the dryness fraction is 0.8. Now we will solve one problem to find out the total volume, total enthalpy and total entropy for the given condition. Here 2 kg of steam at 80 degrees Celsius and dryness fraction 0.85 is given. Let us first understand what is the condition of steam. So mass is given 2 kg, temperature is given 80 degrees Celsius and dryness fraction is 0.85. So here dryness fraction is given in between this X is equal to 0 and X is equal to 1. So the location of the point is in between this B to C. So in between this B to C, the condition of steam is known as the wet steam. So we will write here the condition of steam is the wet steam, and we will apply the formula to calculate enthalpy, entropy and specific volume for the wet steam. So first we will calculate what is the specific volume. So first we will calculate specific volume and then we will calculate the total volume. So for that we have to first find out what is the value of specific volume for dry and saturated vapor and what is the volume, that is Vf, that we have to find out from the steam table. So what is the given condition? Temperature is given. So we will refer here the temperature table. So here saturated water and steam temperature table is given, and in the first column temperatures are mentioned. So here for this temperature of 80 degrees Celsius we will apply the values. Now specific volume for wet steam is known with the formula V is equal to XVG plus 1 minus XVF. But we know that this Vf, that this volume is so much small, so we will neglect or ignore this term and we will only take this XVG. So for this formula X is known, that is dryness fraction 0.85, and what is the value of Vg? So for 80 degrees Celsius Vg is given 3.40715. So when we calculate we will get 2.896 meter cube per kilogram. So what is the total volume? So this is the specific volume for 1 kilogram, but M is equal to 2 kilogram. Therefore we have to take this total volume M into specific volume, and this is the answer, that is 5.79 meter cube. Now we will move for the calculation of specific enthalpy. So we have formula for the calculation of specific enthalpy for the wet steam, that is H is equal to HF plus X into HFG. So we will take the value of HF. Here it is given 334.88 and HFG is also given, that is 2308.7. So if we take this value, then we will put the value HF plus X. X is 0.85, and when we calculate this we will get 2297.33 kilojoule per kilogram. Now this is the specific enthalpy, that is per kilogram, but here mass is given, that is 2 kilogram. So what is the total enthalpy? So we will use here the letter capital H, that is M into H, that is equal to 4594.6 kilojoules. So this is the answer of second question. Now we will move for the calculation of specific entropy. So formula for the wet steam for specific entropy, that is S wet is equal to SF plus X into SFG. So here SF is given 1.075 and SFG is also given 6.5369. So we have to put the value and X value is there. So answer is 6.63. But M is equal to 2 kilogram. So what is the total entropy? So for total entropy we will use here the capital S. That is mass multiplied by weight entropy, specific entropy for wet steam. So answer is 13.26 kilojoule per Kelvin. So here if we observe, the unit is kilojoule per kilogram Kelvin. That is for 1 kilogram this is the value of entropy. So if we multiply with this mass, then this kilogram is getting cancelled, and what is the unit? Kilojoule per Kelvin.